great to be here and that you all made it. Today, I would love to introduce you to the offline first concept and how to implement this to the real world. My name is Gasidlo. I'm a JavaScript and front-end developer. I'm a core member of Team Hoodie, and I'm the organizer of Open Tech School in Dortmund. Thank you very much, Mark, for your invitation, and thank you for your time. I'm super excited to be here. So let's start. So the internet turned 25 this year. Happy birthday! It's really good to see it. In this time, our relationship with the internet changed a lot. We do different things with different devices than like 25, 10, 5 years ago. And it's a part of our everyday life. So, who of you used his phone today for more than 5 tasks? More than 10? More than 15? Yeah. We rely on our devices, the internet, but our needs changed. Like you see, we have reached the breaking point. Since this year, there are more mobile than desktop users out there. In some countries, there already are mobile-only users, like in Egypt, you see 70%, and just to make sure they don't use desktop devices at all. This is a graphic of the technological achievements happened between 2002 and 2012, including the implementations in the main browsers. And like you see, a lot happened. So, tell me, whoever of you tried to work online on a train with a hotspot or a plane? Yeah, it was great, right? Great experience. Who of you did ever a screenshot of an application because they were too scared of losing their data? Yeah. Who of you ever stood like in a supermarket and wasn't sure what to buy and wanted to send a picture to someone like your mom or your friend and realized, fuck, I'm offline? What if your traffic limit is reached? Your hotel Wi-Fi is way too expensive. Your roaming costs are nuts. Those are issues we all know, even from the wealthy countries we all live in. Today, our work, social interactions, our all lives built on being online. If you're not online, it seems you don't even exist. We need new ways to deal with these issues and be able to stay a part of the online community and stay in touch with our friends and family. And the situation is way worse in the rural areas and countries with poor or even no network coverage. Zero reception, unreliable, inconsistent connections are still an issue, no matter where you go. And your experiences and discussions with people from all over the globe have shown that this is a global problem which won't just fix itself in the near time. So we need to accept that technology has reached the limits. So, the applications we use and build for other people. We have to think this topic through. They need to be built offering solutions. Go away from the desktop mindset of permanent fast connectivity. By accepting being offline, it's not a bug, it's a reoccurring state. Let's start and design applications with keeping offline first in mind. There are already some really great offline first applications and services out there, starting with emails, which send the emails we write for us when we're online. Writing down notes, for example, with minutes during meetings, or creating lists we all need to keep us productive with create list, without sending error messages as soon as our internet connection is lost. This would be great. Sending pictures, tweets, or messages during a concert when everybody's doing that at the exact same time. Applications like Twitter store your message. At least it's something because it's not lost, but why not sending it when you're online? WhatsApp syncs here really, really good. I see amazing applications in the future, like imagine you're in an area you've never been before. It's great, and I'm sure you would love to explore it, right? So, wouldn't it be great if your map realized where you are, downloading the map for you when you have Wi-Fi, and make it all available, and showing you like the sightseeing points and the next cafe with hot Wi-Fi, or maybe the next ATM. It will almost make you feel like home, right? So, we want our applications to work offline, right? What do we need for that? Who of you heard ever about the app manifest? And who of you is using it already? Okay. The manifest gives you the possibility to fetch files you'd love to load from the cache when you're offline. So the application will load and work correctly if you hit the reload button. You can still interact with the application on the client side and store data if you use an in-browser storage like local, session storage, and IndexedDB. The advantages are you can use your application offline, right? There's no trip to the network, so the loading is really fast. And when your site is down, nobody cares. The users can still work offline and might not even realize that. To use the manifest, we need 3 steps. The first one is including your manifest in your HTML files. Really simple. The second one is to specify the right MIME type. And the third, you need a manifest. So let's take a look. The first line, you always need that. The second one is like the date and the version number. The cache specifies all the files you would love to have cached, no matter it's an absolute or relative path. Network defines all resources which all just can be used online. And the fallback defines like fallbacks. The first one is the online file, the second one is used when you're offline. You can also generate and change it if you want, or read like this great tutorial by HTML5 Rocks. So, this is great to have that. So, we're actually done. Thank you for your time. No, 10 minutes? I don't think so. It would be great if it would be that simple, but actually it's not. We have to think about some things. Let's compare. Mobile first is a design strategy to help cope with the huge variety of devices and capabilities you see here. 3, but in the same way, offline first is a design strategy to help cope with unknowable circumstances and connection states our user may find themselves in. We know almost nothing about them and can take almost nothing for granted. So offline first is simply the acknowledgement that this lack of certainty extends a bit further than the previous thought. In the same way, it makes sense to build interfaces mobile first. It is the time to think about designing and building applications offline first. With an offline mode that isn't only a contingency for an error scenario, but a fundamentally more flexible and fault-tolerant way of application design. So, what are the main points we have to think about when we create the concepts for offline-first applications? Offline is more than just an error handling. It's about accepting the reoccurring state. We have to ask ourselves, does the app even need to inform the human of the current connection state? Is this information even relevant to the human? And if so, how can this best be done? how can this be a good practice? Why not showing the user the data we have saved in the cache or stored locally? Wouldn't that be great? Always build trust. Can I give the users more trust in the application, like leaving them safe in the knowledge that it won't forget the last state I was in, and that it won't lose any data regardless of what their connectivity situation is, so they don't need to think about making screenshots of applications anymore? And how can I communicate to the human that creating data within the app is still possible offline, and that it will be posted, dispatched, and properly dealt with in the future? This is one of the new concepts for the save icon I really love. There is an unsaved icon. There's a saving cycle with several options, and we have the saved icon. And it works like that. You can see the icon in the upper right corner. The user types something. The state changes to unchanged, then it gets updated, and it's saved again automatically. This really looks like a good practice. Organized data. How can my interface convey changes that occur in the user's current view when they reconnect and the server pushes new and changed data? What to do with deleted items, things that can't be organized in lists, objects that aren't in themselves immutable, like emails? How can I make the unavoidable resolution of conflicts by the human as painless, as intuitive as possible? This won't help anyone. It's great, at least I know that my data haven't been saved, but what can I do now? Doing this all over again, or? And finally, decide. Can the app make a preferred decision on the part of the human and preload any data they might need later? What metrics, possibly behavioral, are there to base these decisions on? How can I word all these scenarios in a way that doesn't worry the user, that embraces offline as a reality without causing problems? These are issues from the user side we have to think about. What does this mean from the server behavior? Meet the staff. Traditionally, the server is like the source of truth. The client was always just like a prophet, and not even that. It communicates always with the server, sending requests, waiting for answers, telling the server what happened, and if the server is not available, the client is panicking and totally helpless and don't know what to do. When we want to post some data, the client sent out a request and waited for a response. The data was stored and the view was re-rendered and reloaded again. With async requests, the client at least was on call and didn't need to wait all the time for the server. A step forward, but still, it was on call. Kind of a really unhealthy, overdependent relationship we all know from at least bad movies. So, let's make the client independent. Times have changed, and so the internet. It empowered us, and now it's empowering also the client. So, with offline first, we want to decouple this relationship. But how shall we deal with these new states? What are the new states, actually? Here are two use cases. If the client understands it's offline and the push will fade right away, great, but what then? Storing the draft? Making a query and trying to send it again after 1, 2, 5, 10 seconds? Blocking the requests? Showing an error? Or just ignoring it and making it disappear like it never happened? Another scenario. The data makes it back to the client, but not all of it. It can be tricky to find out the current connection state, independent if this is a native or a web app. So, should the app show the user just half of the data? Show nothing? show as much as possible, and trying again to resync, can the user change the data then? And how can we keep the frustration level as low as possible? While the user is making a request, like sending a chat message or something like that, the user interface should start by showing that it's a process of unspecified durations. Usually done with this. We all love that, right? Yeah. Based on the different error scenarios, the user interface needs to account for the fact that the request failed immediately, or after a timeout, or only a partial response was received. Timeouts need to be chosen in a way that is useful for the end user. A common default is 1 minute. And I don't want to wait that long. I don't have time for that. And always remember, when it's more than 1 second, you have to keep the user busy. Like preloading images, loading data step by step, and so on and so on. So, in case of a timeout, there should be a user interface affordance by canceling an operation so that the user can apply a shorter timeout if that makes sense in the situation. Partial responses are tricky, but still can be useful. For example, starting to show just top half of the web page or email or other messages. The time it takes the user to read through that might be enough to fetch the rest of the data. Sometimes not enough data is provided to do anything at all, and the user interface should account for that. If a request is not initiated, for example, when a background sync operation is running, the app needs to decide whether the user needs to be made aware of the fact. And finally, a common pattern is to clear a view, then fetch the new content for that view from the server. In every error case, the user is left behind with an empty view and nothing to do. Boring. This pattern should be changed to clear the existing view only if sufficient data exists to give the user a useful experience. In the meantime, it should still be possible to interact with the existing view, if only in a read-only fashion, in case both reading and writing is possible. The first law of robotics is do not harm any human. Do you know the first law of offline first? It's do not lose data. So we always need to store the data. While decoupled the client and the server side, we really need to store it in both sides. When we send the data to the server, we need to kind of flag it on the client side so we know, did we reach the server at all? Just to make sure if another request is needed. Was all of the data sent and stored, or just a part of it, so we can take care of unwanted data duplications? Is this still the same version that I have on the local client side, or did the data change? We need, if this is so, or if not, we need to merge it. I've been asked many times, why not building native applications if handling like offline states is so hard? They already sorted out, right? They haven't. These are also like the conceptual states are the same. And there's more, like you need more development time. Several languages for different operation systems. Web technology always means open technology. It's easy to learn, it's easy to deploy, developing for many operation systems is possible, and we have open data. Not having open data kills the web. The third thing is, offline state is a native app's always an error. On the web, we can handle that differently and more creative. So, this is a lot to think about. I mean, you all are an expert at your field, and you should stick to it, because it's great to do what you love. Stay an expert and let the evolution of the internet make the work for you. This is normally how people imagine how sync works. A really good and smart sync between the client and the server side is like the key to offline first. The concept and also the application. We want all of that to be really easy and fast. That's why we work on Hoodie. Hoodie is an open source and free JavaScript library. It offers you a whole backend with user account storage, shares email. It's offline first, including local storage at the moment. Automatic sync. It has Dreamcode API, which every front-end developer should understand in a second. Hoodie abstracts away all the boring boilerplate backend stuff you don't want to think about. And Hoodie is offline first. And I would love to show you how we handle the states and the sync using Hoodie as an example. There we have 3 stages. We have the front app. It's like the application. Then we have the Hoodie layer. Here we use Hoodie Store. The app only ever talks to the Hoodie API, never ever directly to the server-side code, the database, or not even to the in-browser storage. Feel free to replace the local storage with everything you want. It's your choice. This by itself might be enough. No, this is enough for an application. Always think about, do you need to store data? Do you need anything more on the server side apart from the credentials? You might need not. Your business model might not even profit from doing it. But we want to check out sync, so let's see it. There we have a sync layer, the REST layer, and the database. We can do this because each user has their own private database, which they only can access. You can't share your data by accident, it's all private. So it's very simple for us to decide what gets synced and how to handle changed data. And we have also plugins, which help us to extend Hoodie. I would love to explain a direct message. So, you write a message in your application, then the Hoodie layer gets the message and the task to store it. So it stores it at the local storage and also sending a task to the sync, which looks real. Am I offline, online? Okay, I'm online, so I push it further, I can store it. And if this is maybe an email and we have an email plugin, so the database is giving further the next task to send out the email. They can never talk directly to each other. They only leave each other messages and tasks. It's more like kind of passive-aggressive roommates who are just writing each other little notes. This is all very loose, coupled, and event-based, which means that it can be interrupted at any stage without breaking. Messages and tasks will be delivered and acted upon whenever possible. It's designed for eventual consistency. So, the nice thing in most cases is the front end doesn't even care if the back end is actually there or not. It will hang on to your data, sync, whenever it can, and if your UI allows it, the user can keep on working without interruption and maybe without even realizing it. So if you want true offline capability, your app can't try to talk to the server directly, only through sync, and you always want to keep a local copy in your browser. And sync is hard, it's really, really hard. Don't even think about implementing it by yourself. There's just too much to go wrong. but you can use a lot of stuff which is around. We trust CouchDB for this. It's a NoSQL database that replicates, and this is exactly what you want for sync. CouchDB comes with a suite of features, such as on-the-fly document transformation and real-time change notification we use for our messages and tasks. It also has a version control system, which helps you to manage your data. So when your data is out of sync, it's making intelligent decisions and helps you to merge the data. For in-browser storage, there are others, like right now, we are actually working on implementing CouchDB. It is an open source JavaScript database inspired by CouchDB that is designed to run well within the browser and store all your data locally when offline. It syncs with CouchDB and compatible servers when the application is back online. Remote storage is also an awesome protocol for per-user storage, which you can implement. There's even JSGit. But whatever you do, don't do it by yourself. Remember, sync is the key to offline first. One of the most amazing offline applications at the moment is, for me, it's Prototypo. Prototypo is an offline first, crowdfunded, open source font editor built on Hudi. They store all the data in JSON strings and love the automatic client-server side sync, although they do not use a database yet. But I think this is one of the most inspiring things I have seen in a while. And it's open source, so you really can check it out. And if you want to read the code and show how they implemented the sync. Well, that was pretty fast. I hope I could give you a small insight in the concept of offline first and how to build application to handle offline first, not as a bug, but it kind of really is a feature. And just one quick addition. When you think so much about data, you definitely should take a look at decentralizing it. So make sure to watch about the talk later about that topic by Bastian. It's right after this talk. And if you have any questions left, I'll be around all day and also at the after party. So, thank you.